Good afternoon. My name is Nguyen, and I am a research assistant under Dr. Marizi. And today I will talk about a project we are doing in Rigolab as a lab demo, which is called the Substation Operator Training via the combination of virtual reality and real-time simulation. So substation operator training is a very broad topic ranging from fundamentals such as circuit theory all the way to equipment maintenance or safety. For the purpose of this project, we will focus on station and bay operation training. The trainee is also provided with experience on working with human machine interface or HMI panels. So station level control is a local control room inside of the substation itself, which is a level below network control center. So the control room contains management and monitoring equipment such as control switches, metering or alarms, and protection equipment. This is an example of a station control HMI panels. On the other hand, bay level control is a low-level control that acts as a fallback when both station and network center is not in service. Equipment of bay level control technically serve the same purposes as a station control, but with less functionality. And below is a picture of a bay level control HMI panel. For the real-time simulation platform, we are choosing the RTDS real-time and here are the RTDS hardware we have in Withermore with the RB5 rack on the left and the Nova Core racks on the right. And we'll be utilizing the GTNet card as a communication card between the virtual reality and the RTDS hardware. So this project can basically be divided into two major parts, which is the RTDS real-time simulation, which consists of both hardware and software, and the Unreal Engine 5 virtual reality environment. And between the two, the communication channel would be using a Python code with the UDP communication protocol to send and receive data between the two interfaces. And here is RSCAT, which is the software for the real-time simulation of RTDS, and it is very similar in interface to or like usage as the PSCAT, which is from the same company. It's just the non-real-time simulation version of it. And it's basically can be divided into two parts, which is the draft and the runtime. The draft is where you can grab all the component, let's say the power system component is three-phase source or load, like whatever is a grid that you want to simulate, and then you drag it into the draft. And then you can also drag in, let's say, control component or like an RMS like metering measurement for, let's say, the bus voltage and load current, as well as the source P and Q output. And then you will simulate it. The grid would you will simulate it is in here, and all the data will be sent through the GTNet card. It will send all the measurement data to the Unreal Engine 5 to display it over there, and then it also receive command from the trainee from the Unreal Engine 5 to control the switches on these two load 1 and load 2. And for the runtime, basically this is a SCADA system where you can, after you compile the draft, you can run the simulation, and it will send the simulation file to the RTDS hardware, and where the measurement and metering of the grid will be displayed here in the runtime. But for the purpose of this project, we will be using the Unreal Engine 5 virtual reality to display all this information. Let's say voltage at node 1 or like current at load 1 and load 2. So this is the Unreal Engine 5 workspace. This is where we develop a virtual reality environment for our substation operator training. Because we want our trainee to experience the most realistic environment possible, we basically using a replica of a substation located here in Blacksburg. It belongs to VTES. Basically, if you have wearing a headset, you would, since this is just a development like space, where you can move around stuff or like adding interaction to the equipment and stuff like that. This you will not look like this when you are wearing a headset. Basically, when you are wearing a headset, you would feel like yourself working around inside the substation itself. I would not dive too I would not dive too deep into the working of Unreal Engine 5 itself because this is a completely different topic from the project. So this here is the Python code that acts as the communication channel between the Unreal Engine 5 and the RTDS simulation. This one used like I believe two set of UDP communication sender and receiver to basically exchange data between the Unreal Engine 5 and the RTDS. The reason why we're using two set is because that the package like sending and receiving between both Unreal Engine 5 or RTDS are very different. So we have to use a middleman to like basically convert the package type or like the way they encode it and send it between them. As you can see here, the RTDS would send, let's say, the measurement to this code right here, and then this code would forward that to the Unreal Engine 5. And the Unreal Engine 5 would take in the input data from the user and to control, let's say, the switch of load 1 or load 2 and send that command to the RTDS. As you can see, I'm wearing the headset, and this is a Meta Quest 3 that I'll be using for today's demo. I have already activated the RTDS simulation as well as the Python communication code, and I'll be demonstrating the capability of the VR. So first thing first, as you can see, I can go ahead and look around. Actually, what you see on the screen is actually even narrower than what I see in here. What I see in using a headset basically is almost as wide of a view as a real life. So you can move around. I can move my hand. I can trigger some button. I can just jump a little bit, or I can sprint even. Since this is a early development, then a lot of stuff have not been implemented in the game yet. Let's see, the base station control. I mean, yeah, it's the base station control here. Have not been implemented inside the game yet, and it will be included in the future update. You can move around. Yeah, this building right here is basically the station control. So later on, we will implement a real life interaction where you can use your hand to interact with stuff, not just for right now. We will use this red ray to hit like an object and then interact with the object instead of using the actual physical hand. Because of the capability of this headset, using your actual hand to like touch and then interact with stuff is possible in the future. So right now I have to do, let's say, pointed red ray here as a door and then press a button and then it will open. And then I can go inside. Yeah, basically you see here, this is the replica of a station HMI station control HMI panels. And I have also implemented some metering here, as you can see in control. This switch here is to open or close the source breaker. This red button is to open or close the load 1 breaker. The green button is to open or close the load 2 switch. And to the right side here is on top is, as you can see, this is a voltage at node 1, or basically it's the only node in RMS. And here is the current load 1 second here, and the current through load 2. As you can see, because the source is open right now, so there's no current going through them. And top here is the P output of the source, and the second line is the Q outputs of the source. So let's go ahead and because I have to do this, turn on the source breaker. Close this source breaker first. So later on, because usually in a substation, any control switch need to have a two-stage operation or using two hands. So that will be implemented later on. And now I close switch of load 1. As you can see, the voltage drops slightly, and the current through load 1 is 3.5 amp. And the P and Q output of the source is like immediately jump up to 330 kilowatt and then 571 kilobar. And now I can also close load 2. Yep, as you can see that. Yep, the voltage dropped slightly even more. And but the current through load 2 is 6 amp. And the P and Q output of the source jump up like significantly. I can also try to usually in an actual system you cannot do this, right? You have a load running and then you suddenly shut the source down. But here, this catastrophic like event can be simulated here, and then for the trainee to gain experience into those kind of experience in how to deal with catastrophic events. Like I have a two load running and then I open the source. You see that? You see that a voltage transient like go up to 190 volt and then immediately drop down. And basically you cannot use that in real life, and that's very expensive like mistake. And then you can also close the source. As you see, it's jump up again. And let's say I can go ahead and try to close one and see it. Yeah, if I open the breaker of load 1, the current jump down to 0, load 1, and so the power also drop down. And since this is early development, everything is already like demonstrated here in the demo. So thank you very much for watching, and this is everything I have for today. Thank you.